Good morning. Good morning to everyone. We are going to give everyone just a minute to jump in here, and then we will go ahead and get started with our October 2025 temperature update press briefing. So we'll take just another minute to let everyone get started before we get started. Looks like there's still some folks in the waiting room filtering in, but we will go ahead and kick off with this press briefing. I think this one's a little bit more extended than usual, so want to make sure we have plenty of time. So first of all, welcome. Thank you for joining us for our October 2025 press briefing. Just quick introductions. I'm Kristen Sisner, Executive Director of Berkeley Earth. Joining me on this call, we have Robert Rohde, Berkeley Earth's Chief Scientist, Zeke Housefather and Devin Rand, both research scientists with Berkeley Earth. And we also are joined by Kate Viscara, who helps keep everything running behind the scenes. And we're grateful for her help. So just some quick introductions before we get started. Go ahead, Robert, to the next slide. For those who may be new to our work, we are Berkeley Earth. We are a wholly independent 501c3 nonprofit dedicated to advancing open and transparent climate science. Our funding comes entirely through philanthropic grants, as well as individual contributions and a modest amount of revenue from our commercial partnerships. Our main focus and our mission is to empower data-driven climate action, and we do that through the production of a number of different high-resolution temperature products and make those widely accessible and available. Next slide, please. As usual, the data that you will see in today's presentation is from Berkeley Earth's high resolution surface temperature data set. There's a QR code there to request access. And I think Kate is dropping a link in the chat as well, but this is a quarter degree by quarter degree of resolution. This is an instrumental observational product. We provide subsets for more than 8,000 global cities. We provide TMIN, TMAX, and custom national subsets as requested. And this product is currently updated monthly. Again, if you'd like to request access, the QR code there will link you to the form. And I think the link is in the chat as well. I think that's the last of my introductions, and I will go ahead and pass to Robert to kick off the briefing.
Okay, so hello everyone on this nice Wednesday. So we're going to be talking about conditions for weather and climate in October 2025. It was the third warmest October in the instrumental record going back to 1850. Just a bit more than 1.5 degrees above the 1850 to 1900 average. Behind the Octobers of the previous 2 years, where 2023 and 2024 had El Nino boosted warm events. This year is coming in below those, but still well above any October that was prior to 2023. We'd also note that on a month-to-month basis, the October has ticked up a little bit from September, and it continues what is a bit of a rebound from lows that were registered over the summer, a few months back, but still not nearly as warm as what happened during the El Nino boosted years in 2023 and 2024. So here's another way of looking at the temperature data, with each year represented as a single line from January to December. And 2025 is coming into this space that's sort of between 2024 and 2023 on top, and every other year below them. And we're sort of expecting that the last 2 months of 2025 will be similar. So it fills out as sort of an intermediate between the records that we saw in the last 2 years and what we had before, continuing this upward trend overall. In terms of spatial conditions, October was warm in most areas compared to the middle of the 20th century. Particularly noteworthy warmth in the Arctic, Canada, North America, Australia, parts of Asia, and Southern Africa. I would also call out the North Pacific, is especially warm area with unusual conditions that have been persisting for many months now. Altogether, about 4% of the Earth's surface had record warmth in October. We also had unusual, but nowhere near record-breaking cool conditions in Central Asia. To put this in a little bit of context, this is showing the regions which had record and near record warmth and cooling. There was essentially no areas with record cooling. Tiny bits that were sort of near record cooling, but almost no areas of significant cooling, and some large areas of significant warmth near Antarctica, North Pacific, Arctic Ocean, as well as a few other places. We estimate that approximately 21 countries and Antarctica had record national averages for this month. In particular, I would call out Antarctica, which saw a record warm October. And we would note that in the Berkeley Earth dataset, Antarctica has shown a overall warming trend, although it is the slowest warming of the continents. There has been some scientific debate about whether it's warming at all, but Berkeley Earth has consistently been supporting that a gradual warming trend in Antarctica, which is continued now with record warmth in October. We want to add a little bit of context to what's going on our maps this month and previous months. So there is an unusual gap over Africa on our map. This is due to loss of certain NOAA data services. Since late August, several NOAA weather data aggregation services have been either fully or partially broken, leading to a substantial reduction in the amount of weather stations that are available for downstream applications. Now, we do not rely entirely on NOAA. We have alternative data streams that fill in some gaps, but we do remain significantly impacted by the lack of NOAA data, which leads to some gaps and also increased uncertainties. Just to quantify that a little bit, in a typical month in the recent period, we would expect to have about 20,000 weather stations be active and in our database. In August and September, we're only a little over 10,000, mainly due to the loss of NOAA services. NOAA has been, since the 1990s, the premier aggregator of weather station data. And basically, they gather weather stations from all the national weather services around the world, put it in a common format in a consistent database that lots of other people then access and rely on. And that is coming to affect us, as well as many other groups. NASA also noted NOAA as a NOAA deficits as affecting their work. This results in larger than usual uncertainties, certain data gaps. Our understanding from NOAA colleagues is that this is expected to be a temporary condition, exacerbated in part by the government furloughs, which shut down the teams that were working on repairing the systems, but that it is likely to be resolved during the next month. But we will have to see how that plays out to be certain. And in the meantime, Berkeley Earth has begun archiving data from around 80 countries around the world as an alternative way of getting access to weather station data, going directly to meteorology services and other sources. We haven't yet integrated that data into our workflows, so we don't have immediate access to it in our temperature products, but we are doing this as a contingency for ongoing or future disruptions for NOAA aggregation services. Okay, so I'm going to turn a little bit more back to October. We will note that it's the third warmest land average in October at 2.2 degrees C above the pre-industrial average, the 1850 to 1900 average. 4% of land surface set a record October. It is ticking up, as with the global average. We saw an upward movement in the month-to-month change, rebounding off of the lows we saw over the summer. The oceans were somewhat similar. It actually fell far enough down that it's the fourth warmest October in the oceans, behind 2024, 2023, and 2015. But it is still, fairly warm overall. And we would note that, unlike with the land, there's actually downward motion in the ocean average after a slight rebound in previous months. This may in part be related to the development of La Nina, which I will touch on in a moment. So we have officially moved into a La Nina state. Actually, I would say not all organizations have classified it as such, but some are now classifying it as La Nina. With the cooling in the Pacific that had been flirting with La Nina for a time now, that is likely to bring modest cooling to global averages during coming months. It will have effect on regional weather patterns. Typically is associated with wetter and cooler conditions in the Pacific Northwest, drier and warmer conditions in the South, things like south of the United States, things like that. The current forecast is for a weak and short-lived La Nina, maybe resembling the one from last winter, where it could dissipate, early into next year and return to neutral conditions. I would note that if you look at the map for conditions in the Central Pacific, there is cooling there. It is weak and not very well organized. So this is not a very well-defined or prominent La Nina. It's sort of a weak La Nina at the moment. But we will see how this plays out over coming months. The forecasters are expecting, La Nina now, return to neutral early next year, most likely, and an increasing likelihood of an El Nino event developing middle to late next year. So there'll be potentially a new El Nino cycle next year. Right now, we are looking at a 94% chance that 2025 finishes as the third warmest year on record, a 6% chance that it's the second warmest year, and essentially no chance of it being anything else. Very small chance that it warms enough to be above 1.5 C in the annual average. So we'll probably miss that as well. So about, coming in as the third warmest year, it's still significantly warmer than most of the years that came before it, except for these El Nino boosted years of 2023 and 2024. So I'm going to conclude with a little bit of a scientific aside that's probably mostly interested to scientists, but we have now added the HCLIME weather station database to Berkeley Earth. This was a database published in 2023. It had 3,600 weather stations with temperature data, all of which were stations with data prior to 1890. The goal of the database was to identify resources for long-term climate reconstruction, so pre-1890, pre-1850 resources. As it turns out, the biggest source of weather stations that went into HCLIME was already the Berkeley Earth database. So many of them are duplicates from what we already had. But after deduplication, and we find about 450 weather stations that had not previously been included in Berkeley Earth. Many of these are coming from newly digitized records where someone had taken a paper copy and turned it into a digital record for the HCLIME project. So they don't exist anywhere else. Most of these records are in regions that are already fairly well sampled, though there are some interesting early hole-filling data in places like India and 450 stations in total. In the early parts of the record, it gets up to 150 new stations, 170 new stations in the 1830s. And these sort of, it's a significant addition to the pre-1850 part of Berkeley Earth's database. In the more recent parts, it's only a couple percent of total data, so it's not making much difference. But I would note that there are the bumps here, for in case anyone's interested, are related to short-lived efforts to create national weather station networks that didn't quite gel. So they were around for a few decades and then went away. But that data has now been digitized and made available for researchers. And lastly, I would mention that inclusion of the H-climb database doesn't really change the picture for anything post 1850. The climate change is still the same. For people who are interested in the very early reconstructions, the pre-1850 land-only temperature reconstructions, there are some meaningful refinements there. It's generally consistent with the previous uncertainties on our land-only reconstructed products. But if you are interested, particularly in Europe and North America, where most of the new data is available, you will get some value in looking at the updated data sets. As again, this is probably mostly of interest to scientists working in somewhat niche fields, but it is an important refinement, and in fact, one of the largest refinements to the very early land records that has been available since Berkeley Earth got started. Okay, so just going to wrap up the conversation there and say that the October temperature update should already be available on our website at the URL there or by following the QR code. The next briefing will be in December about November temperature conditions.